right, I'm sharing my screen. You can see a text document on the left-hand side or on the screen right now. And basically, I'm just going to go through what we talked about last week to kind of jog your memory and bring us up to where we need to be for today's lesson. So hopefully you can see that. Hi. All right. So last week we talked about what a database was. We learned that it's a collection of data stored in a computer system. We talked about some of the database management systems. You might have heard Oracle. We talked about SAP, and a lot of different companies have a database management system. Some smaller companies you may not have heard of, but when you go out there and you are actually working in a database management system, you kind of pick up on a lot of the different solutions out there. I work with Oracle and their databases, but have in the past worked on a couple of other types of databases. Ultimately, the databases that I worked on or work with, they all use SQL. And we talked about the fact that there are some database management systems that they don't use SQL. So we've got the SQL version of databases where you can query and communicate with that relational database. And then there is the NoSQL, or there are the NoSQL databases. We are focused on databases that work with SQL. So we talked about what is in a database and everything that you are entering data into. You can assume that that's going into a database, whether you're shopping online or you're trying to get a national identifier assigned to you. All of their data that you're sharing with other folks is going into a database management system these days. It's rarely that I find a company that I interact with that just stores things in spreadsheets or on paper. So structured query language, recall that that's how we're pulling the data out of a database. It is a declarative language, not a procedural language. So we're not manipulating the data itself. We're just querying the data. We're creating data in some cases. We're reading data. We're updating data. We're deleting data. But we are not going into a table and calculating a value and based on the value in a field and storing it back into the database. That is something that a procedural statement would do for us. All right, language elements. So I want to go way back to the beginning and talk about the syntax for a basic SQL statement. And that syntax is essentially, you've got your keywords, select and from, you can see in all caps there. And then you have, after select, your field name, and after from, your table name. And then we learned one of the hardest lessons in some cases to learn is that it always ends with a semicolon. And I read a quote this week that said, I lost 2 nights of sleep because of a semicolon. And if you're a programmer, you understand in the real world sense of what that means, because it can, these little things that you might leave off, they can cause quite a headache. All right, so we have our entity relationship diagram here. And if you recall from last week, we were using a tool called SQLite. And we had a database that we were working with. It was Chinook DB. And if I go to my computer here, we've got the SQLite installed on our C drive. You can install it in whatever makes sense for your machine. And then I also installed the Chinook database. And so going in here. I basically, to open that database in SQLite, just enter the command .open, and then the entire name of that database, which is chinook.db. And now I'm in. And this is the command line that we'll be working with for the rest of the day. And you'll recall that that's what we worked with last week. The Chinook database, we kept to a few specific tables in general. We were looking at values from tracks. We worked with invoices a bit. And we used very simple syntax to pull data out of the system. So we've got, in this particular sample, we've got the first name field from the employees table, and that we find over here in the lower right-hand corner of this diagram. And so if I were to execute that simple statement, that basically just gives me for every record in the table the first name of the employee. And I've got, let's see, what's that? 8 there? So 8. So that was the very simplest version of our SQL statement. And just to kind of get you used to in that tool that we'll be using. We did talk about the asterisk. And if you use an asterisk in your SQL statement, you are essentially using a wildcard. So if I said select asterisk here from in my field name area, it would bring back all records. We also talked about distinct, right? In our basic statement, we're bringing back all records in distinct if we have any values that are the same if in a field in different rows. Distinct will then take out the duplicate occurrences and only show us the distinct results. We talked about the where clause, and that where clause is just building on top of our basic statement here, and we're putting in an operator to say something to the effect of where a field value equals something, or a field value is greater than, less than, equal to. We also talked about limit, because we may not want to bring back from very large tables 90,000 rows. We may want to limit what comes back in our data set, especially when we're first starting out working with data and we're really just trying to get an idea of the sample data. We talked about order by, and that was where we could identify a field name that we wanted to order our results by. So if we're pulling out, say, the first name of employees, we could order by last name. We could see our results by last name. And the order by sorts by, you have either the ability to sort in ascending order or descending order. There we go. Whoop. Descending order, let's get that right. And we could do a couple other things in this select clause area. We could not only pull a single field, or we could pull all fields. We could also pull specific multiple fields. And if you recall, that was simply denoted by placing a comma in between each field name. So something that makes sense for this particular query is we would select the first name, comma, last name from the employees table. And if I came over here and ran that same query, putting the comma in, and you can see I get 2 different field values back. If we put in a comma after that second field, we would get a syntax error because the system only is looking for commas in between the fields. If you enter a comma into that syntax and that's the last field that you want to bring back, when you put a comma in, it's looking and assessing for another field name. If you wanted it to then understand that you wanted the fields from a specific table, it, once it sees a comma, doesn't realize it should move on to evaluating which table you want to bring all those fields out of. So in a sense, this particular statement, it's saying, okay, well, I see the first name field, I see the last name field, but I don't see the from field. And so it's coming back as an error. So be careful with those commas too. That goes back to that statement, lost 2 days because of a semicolon. You could also lose some sleep over a comma. All right, we talked about the and or not functions. And the and or not functions, they were helping us filter down our data. So generally, I want to see all the employee names in my employee table, but I could also say in this statement, combined with where call that when we are working with string text, or sometimes called character or varchar, that sort of thing, you want to denote that your value is a string by setting that off with apostrophes. And so in this statement, I'm combining our where clause with the and or not statement. So where something equals, something is greater than, something is less than, and another factor that we're filtering by. So in this particular example, I want to see first name, last name values from the employees table where the first name is exactly Jane and the last name is exactly Peacock. And if I go ahead and I execute that, it does find an exact match for that in the table. And that is a basic way of using and. You could say similarly, I want to see employees where the first name is Jane or the last name is King, and then we would get completely different results. Now we're evaluating on a different set of parameters. So I said in this particular statement, I want to bring back data where the first name is Jane or somebody's last name is King, and actually finds 2 values and it brings back 2 values. So not similarly, I could ask it to bring me back records where the first name value was not equal to Jane. So that's another version of that. All right, between the and the where, we took a look at, we could say where something is greater than or where something is less than. We talked about between, and between is a nice way to kind of shorten our statements. So we say, I want to see data where the invoice date is Jan 1, 2020 through December 31st, 2020. In that one, we would simply write out, I want to see, select invoice date from invoices where invoice date is between, between invoice date. All right, so let's go back to that. Let me try to explain that better. So select invoice date from invoices where invoice date between, and then you'd have a high value and a low value. So your low value would start at the beginning of the year, and your high value would end at the end of the year, and that would be the range that you want to see those invoices for. And so that was the between function, and the between function is really just a short way of utilizing or writing out an and comparison. Similarly, not between, that was a way for us to not look at a range within, but a range outside of two comparison values. So the opposite of between. We talked about in. In is our way of shortening out our statements where we're saying, I want to see records where the last name is King or the last name is Peacock. When I write an in statement, it's essentially, I want to see values. Let me bring up my little guy here. So essentially what we would see with an in we take out our equal sign. And in this particular example, we're searching for strings again. So I do want to separate them out with those apostrophes. But in this example, I want to bring back records where first name, last name from the table. I want to see where employees, their last name could be Peacock, their last name could be King. And we have a similar rule here with our commas where we are not separating out that last value. We're not following that with a comma. We are encasing our values within parentheses, and we don't have to check for strings. It depends on the field type. If we are searching for numbers, then we just put the number in there. You don't have to offset that with apostrophes because only strings and dates require that offset. So the syntax, I'm bringing back first name, last name from that employees table where the last name value found could be Peacock or it could be King. And that is just a faster way of writing out everything that we have up here. If I did where last name equals Peacock or last name equals King. All right, got the wrong line there. There you go. So where last name equals Peacock or last name equals King, you can see we've kind of shortened that statement down to just an in clause. We also had a not in, of course, and that is the opposite, where you didn't find these values in the row, it would bring back those values. Similarly, we had like, and like we did not know the exact value we wanted to bring back. So in this particular example, I know that there is somebody in the table with a last name. I can't remember the exact spelling of the last name, or somebody has entered in 10 different spellings and I just need to find matches based on a smaller segment of the value that they've entered in. So if I go out and I say, bring me back all those first name, last name records from employees where the last name is like, I use a wildcard % symbol to let the system know, bring back any variation of that, and then bring back where the exact ending of that particular statement is EACOCK. And you can see it finds one example where that's a match. Similarly, I could tell the system that I know the first parts of the value, but I can't remember the last part, I put that percentage symbol at the end, and then it brings back the record. So that is the like operator. It's very powerful. And then, of course, you can build on all of this, where you can do it is like a one something, or it's like another something. And now we're starting to build in combinations of all of our different little operators that we've been learning about. Okay, so I'm going to bring up our presentation for today. All right, just want to make sure that you guys can see what I am showing. You should see a screen that has a slide that says SQL Session 2, November 6, 2021. Can everybody see that?
Yeah, we can see that.
Okay, great. Thank you. Okay, so today we did our little overview. Today, let's talk about where we are going from here. We are talking about aggregate functions today. We're using in combination with aggregate functions something called a group by clause. We're going to talk about joins. This is where the power of a relational database is really brought to the forefront. And then we'll be talking about subqueries. So go ahead and get settled. We're going to go on a journey here. Now, I want to point out some housekeeping of how the morning will play out, because we want to insert a couple breaks. So at 11, I'm going to have you guys break for 15 minutes. And then at 12, we'll do the same 15 minutes. And that'll give you a chance to go to the SQLite tool and maybe experiment with anything that we've talked about in class. And it also gives you a chance to kind of get up, stretch, move around a little bit. Okay, so aggregate functions. Shall we begin? So aggregate functions are defined as trying to get a version of this that you guys don't have to look at these notes, but that is not working for me today. So aggregate function, the set of values that are used in aggregate function are you'll reminded of them and from, like, if you've taken statistics classes, average, max value, min value, count the occurrences of a value, or sum, which is our total. So what they do, in easy definition to remember, is they just basically take a collection of values or matches that they're finding based on your query, what you've identified, and they're returning everything in a single aggregated value. When we deal with these different aggregate functions, we see that sum and average are used for numerical values, whereas min, max, count, you can use that with a numeric or a non-numeric value. And then again, these are used in conjunction with the group by clause, and we introduce the concept of null and how the database handles null values. So take a look at this screen. We have a table full of track names, an ID that signifies which album that track is found on, the type of media that track is stored on, the genre, and then the composer. and we've got an ID column for each one of those. But if you look, we have a field here that has a value null. And essentially, it is the database's way of demonstrating that it either does not know what that value is, it's missing. We didn't provide a value for that field, or it's just not applicable. And so if you are working in a compiler and you see this in your record set, a lot of times you will see the word null, uppercase, lowercase, within parentheses. Each compiler kind of has its own way of displaying that. So when we work with null and we work with our aggregate functions, we need to remember that the null value represents either an unknown value or a missing value, of course not applicable, but the null is not 0 and it's not an empty string. And both of those things are denoted differently when we're writing our SQL queries. And then null is not equal to itself because there's no value. So if you find null in a table, this is a great note. It means that that field does not require a value. When you get into database design, you'll find that certain fields in a table have to have a value, or you cannot set up a relationship between that table and another table. But when you see a null, you essentially, you know that that particular field was not set up with that restriction. All right, so let's work with the count function. The count function, it basically counts the number of records in a table. And you can see that the syntax there is select, we go back to our keywords, count, and then we have these parentheses. And within that parentheses, we actually identify the column where we're counting the number of records we're counting the number of records found for a specific column from our table. So let's take a look at that. Now this is a little small, I apologize, but we're on the left-hand side here, we're looking at the student info table. And the student info table, we have a column for student ID, first name, last name, gender, state, country, the field of study, and then the start date. And so if we want to find the count of first names from the student info table, we set up our query like this. So select count, I want to base this on the first name field. All right, let's rewind and go back. Thanks for letting me know that. The count function. So we're looking at our student info table over here. We've got our keywords from our statement, and then we start with that identifier count, and that is our aggregate function there. In parentheses, we put the field name that we want to count values for, and we are pulling that out of the student info table. So if you're looking at this particular table, you execute that function, it actually goes through and it doesn't show us every value in that table. It brings back 32 matches. So we specifically in that example said count the number of records with a value in first name. If we don't need values from a specific field and we just want to know how many records, then we have a wildcard. And you saw this wildcard in last week's presentation. This one is where within those parentheses we put an asterisk. So this is our asterisk buddy back. Okay. When we use the count function, it is returning even records that have a null. So if you want the number of non-null values, that's where we have the difference. between using this count everything versus count specific field values. So this will bring back 32, but if you do a select count asterisk, it could bring back 45. It depends on how many records are in that table. Next aspect of writing out SQL is using an alias. And this is nice, especially when talking about aggregate functions, because if you are typing out a field declaration here, count parentheses first name, you can see that the field header comes back is count parentheses first name. And when you are delivering data sets to customers, that may not make sense to them. And so we have the ability to use aliases to clean up the results. And also, if we're using aliases not with fields but with tables, it also makes the script easier to read and work with. So we can add an alias to rename a column or a table. And you'll notice that this particular example for column name, they have this little as identifier here. This is where you can, the long way of writing out, if you see a column name, if I select a column name, I actually want to report it back as a column header as something else. I'll show an example of that. You can similarly do that for tables. You can say this table, this long named table, I want you to actually refer it to as a much shorter name. It's easier to read. The as keyword is optional. It really comes down to your coding preference style. Typically, you will see as when an alias is identified for a field, but you don't normally see that as identifier if somebody is providing an alias for a table name. All right, so we're going to work on a query. Wish I could hide these notes. Can you guys see these notes in the lower left?
Yes, we can.
Yeah, I don't want you to see them because then they have the answer. Okay, so back to our ERD, our diagram. We want to find out how many invoices are in the digital music store. So invoices, we have an invoices table, good place to start. And we want to integrate that count function that we learned about. So I'm not interested in bringing back the number of values in a field. I want to know how many records. So that defines whether or not we use our example where we're putting in the field name or we're using that asterisk. So if you have your compilers open, your SQLite, I'm sorry, I keep referring to it as compiler, but it is this guy here. Okay, we're going to do a select count wildcard from the invoices table. And it brings back 412. Now, if you change that up a little bit and you said select from a specific field, you may get a different value. Let's see, I haven't tried this one. One thing we talked about last week too, that I didn't bring up, is that your select statements are not case sensitive unless you are referring or you are denoting a specific string value. When you get into declaring these string values for your where clause, then your string values do assess for case. There are functions that you can use that handle for that, make that a little easier, but our basic statements are not considering case. Looks like we have as many billing addresses as we have for invoices. So 412, 412. Anybody have any trouble with that particular example? Okay, count distinct. So similarly, we have been counting by specific column name, and then we've counted records, total records in a table using that asterisk. What if we only want to see unique values? In that case, we use the syntax count, parentheses, distinct, and then for a specific field, we put in that field name. Let's take a look. All right, so back to our student info table. How many unique values are there for the field of study? We'll call that field of study. You can see in our data, we have some duplication. So where I find multiple students that are studying for DevOps, or I have multiple students that are studying as a back-end developer, I don't want to see the count of where in this field there's a value. I want to see specifically only where we have unique values. This, I'll say a practical application of this is if you have a field within your data and you don't know how many different values are permitted in that field and you want to set up some filter. I want to filter out the status of something. Well, do you know if that field stores only active or inactive? Does the field store the values active, inactive, or unknown? So depending on how many different values you have that are stored in that field, this particular count distinct may help you determine, at least in the database, how many distinct values are being stored. So this is one application of that. So our syntax is going to be, again, select, then we have our count, parens, distinct, and then the field name. And then what they've done here is they have put in an alias that we just talked about. So instead of the result set coming back and putting this entire thing in my column header, it is much easier to read, and it comes back. It's the count of different fields stored, different values in the field column that are stored in this table. And so we have, in our example, we have 6 different fields that we've entered into the table. And again, if I just did a count of field, I'd get a much different value because it doesn't care if it's a unique value or not. If it sees it again, it counts it as 1. Also, one note about this, we talked about this a bit ago, it is also bringing back, it's not bringing back null values. So it's bringing back values only where a value is found. And it's only bringing back the count for distinct unique values. So if I had fields here where I did not have a value, it would not count those. It does not count null. All right, back to our diagram. How many composers are there in the digital music store? This time we're going to the tracks table. And so for this particular example, we want to see how many composers there are in the digital music store. We're not concerned with what the composer names are. We're not concerned with which tracks belong to which composers. Those were some examples that we used last week. We specifically only want to know how many different composers we have. And so in a tracks table, you may have the same composer on multiple tracks. So when we hit this, it brings back 852. So to kind of give you a comparison of another version of this statement, I want to count in the composer field, the number of values in that composer field. So if I take out that distinct, it comes back and it says, well, in the whole table, you have composer, it occurs 2,525 times. And then if we kind of whittle that down a little more, if I say, okay, select how many records we have in tracks, you can see we've got 3,503 records in tracks, in the tracks table. So that tells me that I probably have some nulls in that composer field. And that's why when we search for values in that composer field, it brings back a much lower number than the total number of records in the table.
Sorry, Kathleen.
Yeah.
I understand that all our students are very happy with the class because we missed our break time for 5 minutes, but nobody asked for it.
No, she mentioned that she's gonna have the break at
Okay.
11.
11?
Okay.
Is that all right?
We have a break time, but if you continue, don't worry.
Okay, so you're saying you usually break at 10 till?
No, the break is 10:45, and we will have like 15 minutes and coming back at 11, as I know.
Okay.
Yes.
Then let's see what we're getting into here. Min-max. All right.
Let's give you a 10 minutes
11:05,
break for
yeah.
this time.
Say that again. I missed that. What'd you say?
It's going to start at 10:05 right now because like we already 5 minutes past, from our breaks. That's the things I think we tried to mention, I think.
Okay. I kind of set up a break time of 11 to 11:15. So if we want to go ahead and just start the break now.
Okay. Okay, sorry.
We can go ahead and do that. So come back at 11:05 Eastern. So roughly 15 minutes from now, and I'll get started at that time back with our min and max. Does that sound doable?
Yeah.
All right. Thanks, guys. Hi, guys. Welcome back. Hope everybody had a chance to get up and stretch and dance a little bit to that music. Let me get us back up to speed. I've been trying to resolve that pair deck problem where you guys can see the magic. So I want you guys to see the answers. It's no fun that way. All right, I think it's fixed. Can you guys see that screen, min and max?
Not yet.
Not yet. I put a link in the chat for what it's telling me this particular pair deck session is. I'm not sure if you were in the pair deck from the first part of class, if it kind of dropped you out of there. So those of you that were following along in pair deck, give that a test. You should see in the presentation, I'm just switching between screens. Okay, so you can see, I'm going to test that out. Can you see that switching in Zoom from one screen to the next?
Yes,
Yes, we can see.
Thank you. All right. The beauty of technology. It's amazing what we can do with technology, and it's amazing how we adapt when it's not working. But if we didn't have issues with technology, many of us would not be working in the career we have, which I love. I love what I do. All right. So min-max.
Can I ask you a question before we jump in there?
Sure.
Yeah, just to clarify myself, are we still dealing with the same Chinook DB like from the last time, or are we working on
We
something else?
are. We are. And
We are.
I'll bring up that database. The examples that are used in the kind of the overview screens when we introduce the topic, that's not a database. That's not a table in Chinook. That's not part of the Chinook database, but that it's just kind of designed to give you another reference point. So if you try to run those scripts, you're not going to get results. So as an example, the student info table, this one. So the student info table is not in Chinook, but if you want to kind of do those things on your own, the ERD does have all of the tables that you would find in your Chinook database. I don't know if that's helpful.
Absolutely. Thank you.
Okay, and next. I am keeping a log here of what we have talked about. So we're still early in the aggregate functions. See, all of this is a review from last week. So aggregate functions, we've worked with count, and we talked about nulls, and we talked about aliases. So keep that in mind as we go forward, because it's all going to build on one another. It's layers upon layers. So min function, take a look at that syntax. Very close to count. So the only difference there is instead of that count little function name, you've got min. And again, in this example, the min function and the max function, they're going to ignore null values. It's only evaluating on what a specific value that is stored in the table. Because if we ran min and it actually assessed null, then every time if there was a null value in that table, we'd get null back. So let's take a look. Who gets paid the lowest wage in the company? Who is getting a raise? Because fortunately, somebody is paid the lowest. So in this example, we've got our employee table, we've got their salaries, we've got their job titles, we've added a gender value here and hire date. So what is the minimum salary value in this table? You can see they've added an alias here. So instead of bringing back as my column header min paren salary, it's going to bring back lowest salary. Easier to read. And we go through and kind of manually assess the values in the table. We can actually find that that lowest value is indeed 55,000. All right, we used that previous example on a numeric value, but we can also use that on dates. And if you recall back when we were first talking about this, your min and your max, those are going to be numerical values. And you can, of course, you can also assess date. So in this example, what is the minimum hire date? What is the earliest hire date? And we go through, and if we do a manual check, see our earliest there is in 2017, and that's what comes back. So in our example now, what we want to do is we want to select the track that is the shortest in duration. And so if we're taking a look at our tracks table, we find that there's a milliseconds column there. You want to go ahead and play around with the syntax that we've just seen. There we go. And I'm going to identify that I want the milliseconds field. I want to assess for the min value from the tracks table. Go ahead and I hit enter there. Excuse me. The shortest track in milliseconds, 1071 milliseconds. Max. I think it's probably easy to say that where we saw min here, similar to how we saw count here, when we start assessing for max, that's going to be your difference there in your syntax. Now, what is the highest salary amount in the table? If you're following along and you're entering your values into the SQLite, you can come here, and if you're at your command prompt, you can hit your up arrow, and it will retrieve line by line the historical entries that you've got in the table. So if I want to speed up typing this query out, I'm just going to go up 2 levels, change that min value to a max. Now it does not include the from. I'm just going to type that at the end to kind of speed up that execution. So select max milliseconds from tracks. What's our value? We have 5,286,953 milliseconds. A lot of milliseconds. All right. In our example, though, it's assessing for highest salary. Go through, we can see, yep, highest salary. So I just went through and I kind of gave you the example in the SQLite for what you would type out for the max function, and want to kind of build on that a little bit. Okay, in this example, I want to go out and I want to find the max milliseconds for the duration of my tracks, and I want to bring back the min milliseconds for the duration of my tracks. So building on what we learned last time, we're assessing for multiple fields, or in this case, multiple aggregates. If I go ahead and I hit enter there, it brings back the 2 values that we just saw, our 5 million and our 1,000. So that's just kind of taking that concept and building on what we've also talked about. All right, sum and average. Sum and average. So the sum function returns the sum of a numeric column. You can see that the syntax there is mind-blowing, pretty much the same thing that we saw for count, min, and max. So let's see an example. What is the total amount salary of the employees? Sum. I'm going to add up all the values in the salary column and return a result. And I'm not going to add it up, but if I had a calculator and I manually added up all those values, I would get 836,000. I'm taking it a step further, where now we are adding on that where clause. We want to see what is the total salary where a gender equals male. And that is this example that you see down here in the lower right. So essentially the syntax we're working with, and now I'm adding in a filter, a comparison. Okay, test time. How much did our store earn? In earnings, you're going to want to look to the invoices table, and we are interested in summing up the total field. So that's not visible to us right now. Go ahead, and when you're kind of working this out in your head, you're going to want to use the total field. Sorry if I said table. Let's go ahead back to here. Okay. So how much money did our store earn? Our store earned, and this is the total table, so I don't necessarily have a date range that I'm pulling back from this particular query. We earned $2,328.60. So a way to further define what we want to see come back, we could add a date range. So there is a field in that table where we have invoice date. So if you wanted to build on the query that we're looking at here, you could use this same query that we just used, select sum total from invoices, but then you would invoke that where clause and you would put a comparison operator for the invoice date field. You'd add a comparison operator. You could use between, that between function that we talked about. So there are a couple different ways where you can then start breaking down the data to be more, I would say, more helpful to whoever is actually reading your data. Okay, so we're going to do a 2-minute challenge. And I want to see you go out to Google and I want you to query how to bring back distinct years from a table. So if you go out to Google and you do a search on, if you go out to the internet and you search for SQL, you're going to get a lot of results. One site that I always go to for my I gotta jog the memory from time to time. I usually go to Tech on the Net, but you're going to develop your own preferences to whatever site is actually presenting an explanation for you, the explanation that you kind of understand the best. There's plenty of aspects out there, but let's see. Just want to note that if you go out and you are using a specific database management solution, what comes back in your date range search? So SQL distinct years from date. Depending on the RDBMS, you're going to get different results. So one result that works for, say, an Oracle database may not work for an Access database. There are nuances to how you have to form up your functions and what functions work. And I just went in here, I went in SQL distinct years from date. So go ahead and do a little research. I'm going to give you 2 minutes to kind of do your own research, and then I will circle back with you. So 2 minutes, and I will be waiting right back. All right, how did it go? Another way you can Google this is SQL year part from date. Brings back a SQL Server year. You can see that there are options. There are year, date part, different functions. bringing up another option for us to search. All right. So if you try to put in year in your SQLite, you may get an error. So instead, what I'm going to do is I'm going to change my search parameter here. I'm going to say specifically SQLite, get year apart from date. And then this is another good resource that I've used from time to time. It's the W3 resource. And we see that SQLite has its own function. So strf time parens. This will be how your page is set up. Often you'll see that they give you the syntax. Then you'll have examples, and they may build on the examples and make them a little more complex as you scroll down through the page. And so when you're doing your research online, it's a pretty standard way they lay out the definitions or the explanations. So we have a suggestion by the interwebs that we are going to try. All right, so in our particular example, we want we want to know how many distinct years are in the invoices table. So if we write out that particular query as select distinct and that strf time, we need to put in a variable that that particular function understands. So we go back here, we can see that what this particular function is looking for is it's looking for a format. It's looking for a time string, a modifier, and then it looks for multiple modifiers following. So an example here is if we put and we search in SDRF time, and I put in, I want you to bring back the year, I want you to bring back the month, and I want you to bring back the date value for right now. Then if we run that, we'll get a result based on what is what our computer stored in terms of now. So when we come here and we say, I want you to bring back the year value, that is the code for bring back the year component of a date. And I want you to bring it back from this field. If I go ahead and I hit enter on that one, it brings back the distinct years that I find in my invoices table. And so if we go back to what the challenge is actually asking for us, how many distinct years in the invoices table, we've actually brought back what we were hoping to see. So recall, and this is important, if you try a function in SQLite that you may be using in another database, it may not work. Don't get frustrated. Just Google your answer. I Google all day long when I work with SQL because there are so many variations of how you have to write things out that if you haven't used something in a long time, you just need a little help. And that's why these resources exist on the web. They're great. All right, so average function. Let's move on there. Average, same syntax, is just the keyword AVG. And then in this particular example, we want to see what's the average salary of our employees. Well, that's kind of hard to just look at a glance. Thank goodness we have functions like this. But of course, if you had a calculator, you added them all up and you divided by the number of values, you would get $83,600 as the average salary for our employees. So what we're going to do is we're going to find tracks that have a duration larger than the average duration of our track. So essentially, we want to find out what are the long running tracks in our database here. But we are going to be going back to the tracks section, and we are going to be using a query that we've already kind of worked with, and that is our milliseconds from tracks. And so in our example, if we execute and we say, select the average milliseconds from our tracks, we get this value. We get 393,599 and some change. So that answers one part of our challenge here. The next part that we have to find out is we have to then do a comparison. So I have the average. Now I need to find out which tracks run longer than the average. So because we're building and building, we're going to actually use a second query here, but we get to the point in the course where we don't have to execute multiple queries to get the answer to this. We just have to write one. So let's build from there for right now. So select star from tracks where milliseconds are greater than this value. So I've already found my average. Now I just need to find any record that is longer than our 393,000. Okay, missing a what? I don't like hold in. I'll let it happen to you. All right. So we look at all of these results and we find that we've got quite a few tracks that are longer than the average. This is a lot. These are a lot of records. So something that I might do, kind of get a little baseline of how many records I'm looking at. I might build on that. And I might say, okay, well, just count the records from tracks where milliseconds are greater than our value. And it brings it back 494. So that is obviously less if we were to go in and say, well, select count the number of records from tracks. We have 3,503 records from tracks, so only 494 actually run over a certain time. And so that is just kind of building on that concept and performing further analysis on our data. Group by. Group by now, we also use that in conjunction with our aggregate functions. So let's talk about a little bit about what group by is. So group by, that is going to help us add some context to the results of our aggregate function. So in an example like this, we want to count not the gender, the occurrences of a gender value, but we want to count where gender equals a certain value, and we need to build out not just where we've seen in our previous examples. We might have said we might have had this as our previous example. I want you to count the number of occurrences of gender. I want to break it down further, and I want to see how many occurrences of one gender versus how many occurrences of another gender. What we've learned so far is we would have to execute two different statements for that. One to see how many times it found a value for male, how many times it found a value for female. So this is allowing us to apply the aggregate function to a group of rows. Take a look. So the syntax for this is we have, similar to what we've been seeing, we have our select and then our aggregate function, and we've identified the column. But then we want to add an additional piece of information and bring that back to help us see a little better detail. We've got our table name, and then we're grouping by, if you notice, this matches this. So we're grouping by our first column, and in our second column, we want to see the result of the aggregate function. So group by, it returns only one result per group of data. So going back to what we were looking at, male, female before, it is only going to return one record for the count of male, and it's only going to return one record for the count of female values. It's always following the where clause. We've talked about this ordering of clauses in the previous class, where obviously we see that the from clause follows the select clause, the where clause follows the from clause, and then we see another one now where group by is always going to follow the where clause. Group by, it always precedes order by. So putting it all together, we talked about order by in the last class. This guy just slips in between where and order by. Okay, so group by with the count function. That's going to be the example that we're working with right now. So going back to what we were just talking about, we want to see the count of all the differing values in the gender table. So this particular table looks like it has two values for gender. It's recording male, it's recording female. So I want to bring back the values that I can count. I just want to see what those values are. So if I put the gender field here, it is going to bring back one record for each different values. So it finds two different values. I get one record for female, one record for male. Then I want to see the aggregate of those two separate values. So I want to see how many males we have, how many females we have. And then because we've put this field name here, we have to let the system know that we're actually grouping by that field name. So that's where we're telling it that whatever results you find in that gender field, then we're going to group our aggregate value by that. And so in our group by here, we've got gender. A little different example of that is previous to before we go into that. Just note the group by clause groups results before calling the aggregate function. So when it's going through and it's assessing the table, it goes through, it says, okay, well, how many different values do I have to group? And then it executes that aggregate function. Otherwise, if it just executed the aggregate function first, you would get the value 10, and then it's a completely different evaluation if it's saying, well, first evaluate X and then evaluate Y. When we leave gender off, that's where if we're just counting gender, we would have gotten a 10. But we need to tell it when we're using group by how we're segmenting out each one of those values. Okay, so here's our example. So we're going back to our employees table. We are looking for the number of employees working as a data scientist broken down by gender. So when we take a look at this table, we can see that job title, if we were just doing a count where we're looking for the job title data scientist, it would bring back, let's see, I see it twice. But now we're adding a further filter to that, a further way of breaking that data down. And we're saying, but I want to see that value based on gender. So based on the differing values in the gender field, I put gender here, I want my aggregate function to add up the number of times I see data scientist for the different values here. So I see male, I see female. So for each male, for each female, how many data scientists do I find in this table? And so We want to see our gender field come back first. We want to see our aggregate value come back second. And I'm specifically saying in my where clause, only where it finds a job title equal data scientist. And then I'm grouping by gender. And just note that this field matches this field, and we're going to keep that in mind as we move forward. So when we execute that particular query, we see that sees two different genders, and then the occurrence of data scientists for each gender is one. So we've got one female data scientist, we've got one male data scientist. A note about the group by clause, it operates on the data before the aggregation. So in that particular example, it went through and assessed how many different values we had for gender. The where clause happens before the group by clause. So it is actually assessing that comparison. Okay, find all the examples where I have data scientist equals job title equals data scientist. Only rows that meet the condition that we've specified in the where clause are grouped. So we didn't see, when we said where equals data scientist, we didn't see DevOps, we didn't see other values because we narrowed down the result set first by saying only data scientist. All right, let's take a look at our Chinook database and let's see what we can find out. All right, find the total number of each composer's track. And what we want to bring back is we want to bring back the name of the composer and a number. A number, essentially the count of how many tracks that particular composer has in our tracks table. Okay, so I want to find the total number of composers' tracks. So first I want to separate it out by composer. So since I'm separating it out by composer, I'm bringing back that value composer, and then I'm just telling the system group it by the different values of composer. So one line or one record for each different composer. And then where you find a composer, how many tracks do they have stored in the table? And I'm counting. So if I go through here and I say, oh, it's a lot of data. So we'll just start towards the bottom here. I found Antonio Carlos Gobim. Looks like this whole thing is the composer name. Bad example, but this one's easier. All right. Waters Right. Waters Right has one track. These folks here, Jimmy Van Heusen, Sammy Kahn, they have 3 tracks in the database. So if we try to figure out a little bit more about how many tracks we're actually looking at there, I want to count the distinct composer from tracks. Happens. All right, use the wrong word there. Get used to it. I'm not doing wrong. Okay, so going back to a previous example, how many distinct composers do we have in the tracks table? 2,525. And then what we did in our particular test here is we brought back for those 2,500 different composers how many times we saw a track. Let's take a look. Another example of, I want to group my composers and I want to see how many different times that composer occurs in the table. So a little different way of writing that. And then one more way that we might see that written. I want you to bring back the composer name and the count of tracks. And I only want to bring back values where the composer is not null. So we're getting the same assessment of data 3 different ways. So looking back at our database, how many customers do we have from each country? And I want to see in my result set the name of the country and the number. So if we're just building on what we saw with composers, we could probably adapt. I want to use a different table. All right, there back on track. All right, so I want to see how many customers we have from each country. So going back to our customers table, go through and we see we have a country field. So first I want to see for all the differences that I find in the country field, how many entries do I have? So again, customers table, country field, start writing that out. So select country and then a count of records that come back with a value in country from that customers table. And again, I'm grouping by that first field. So what comes back is all of these various counts. And I see we have quite a few different countries. Moving on and building on that example, I want to see a country and then city breakdown. So in this example, it's grouping Germany and it finds in the table we have customers, 4 customers in Germany. But then I want to see it broken down by city as well. How many customers do I have in a specific city of a country? And so we talked about adding on different fields, separating them out by comma, and that also includes our aggregate here. So country, city, count separated by comma. We've added an alias in here of number of country and taking it from customers, and I'm grouping it. Now take a look at the group by. This is what's different in this example. We're selecting the country and the city. So we need to tell the system that we need to group it by country and city. And just an easy way to kind of an easy wash or assumption you can make is whenever you have fields before your aggregate function, those fields need to be listed here. If they're not, you're going to get an error. So then we had Germany before where we had 4 different occurrences in Germany. Now it's further broken out Germany. We can see we've got 2 in Berlin, 1 in Frankfurt, 1 in Stuttgart. And where we had this guy. If I take off city, I get a strange result back. So I get Germany, Stuttgart, but my other 2 records are missing. So remember, when you're grouping by, put these field names, put the field names that you are actually saying I want you to show in my table, make sure those field names are actually accounted for in this group by section. Okay. Group by with min-max. Group by with min-max. Now, we were using min-max with numbers and we were using min-max with date. Our example was we were looking for min salary amounts and max salary amounts. Now we want to see that by gender, right? So minimum salaries by each gender. First, I have my gender field and then I'm grouping by my gender field. So again, I'm accounting for that field in my group by. Then I put my min salary here. In a previous example, we didn't have gender broken down. We just can get rid of group by, and we just did a select min salary, and it showed us the lowest salary occurrence in our database, in our table. Now we're saying, well, break that down further by gender. Let's give that aggregate function an alias so it's easier to read. And then it brings back and says, okay, so your female population is making $67,000, a minimum $67,000. Your male population, they make a minimum of $55,000. And of course, if you go through and you track all the way up and down, separate out by male or female, you should find those values come back. So here's our lowest salary amount for male. And then we have our lowest salary amount for the occurrence of female. Okay, so group by and then order by. So we're bringing order by back in the mix. So in the maximum salaries of each group, if we say are using the max aggregate function, we can also order as well as group by. So we're grouping by, in our example, we're using grouping by gender, male or female. Now I want to see that sorted in, I could do alphabetical order ascending, I could do alphabetical order descending. And so our example here, we're actually going to order our genders in descending order. I'm sorry, our salaries in descending order. So order by follows group by follows where follows from follows select. So again, selecting gender, make sure we're grouping by gender as well. There's my aggregate. I've given it an alias from the employees table, and then sort in descending order that salary amount. So for male, the max salary it finds in this table is 110,000, and for female, the highest salary amount it finds is 95,000, but 110,000 is a greater number than 95,000, and so you see that listed in that order. Okay, so we're going back to that minimum duration, or that duration of track, and now we want to bring back the shortest track from the tracks table, and I want to see the album that track is on. And so for that particular example, in that particular example, I want to see the field's album ID and then that minimum duration. So I'm building out, select my album ID field and then calculate that minimum duration. That is found in that tracks, that milliseconds is found in tracks. We've seen that already. And then because I want to see that album ID field and group by that album ID field, I do need to account for that in my group by class. Go through. And then, well, I didn't say for each track, so hopefully you guys read that. So for each track, the minimum duration for each album. So album 345, the shortest track on album 345 is 66,639 milliseconds. Could we build on that further? We could. So let's go back here. album ID is not really helpful. And so you might want to go through and bring back a more relevant result set. And maybe that, maybe composer would be more meaningful. You're not really concerned with the album, but you want to see, based on the composer, the shortest song. What's the value of the shortest song? So you could easily change this back to, drive me bonkers.
Can I ask you a question real quick?
Sure.
It sounds a little stupid, but how did you copy and paste all that the queries at the same time, like the multiple lines?
Remember that cheat window? They're stored there. But similarly, if you had your script written out like in a text file, let's go ahead and take a look at that. I'm copying it because I don't want you to have to sit here and look at me type everything out. All right, so then that's a similar record result set, but instead of looking at by album ID, I want to see it by composer, and that is how I bring all that data back. Let's go back to your question here. So in my notes that I'm working from, I have the select statement written out like this. So if I just go through here, oh, it's automatically executing. That's
Yeah, I tried exactly the same thing, but it just gives me one single line instead of giving me multiple lines.
Oh, it doesn't put in all 3 lines?
No, I'm just getting one single line on like select the album ID, and that's the one line, that's the only one line that I'm getting.
If I use the up arrow, because it does separate out each of those lines, the way that you're seeing in my tool here, my SQLite, if I use that up arrow, that happens as well. I mean,
if I do scroll up and down, and I will be able to see what I typed in, but not the one that I was copying and paste those 3 lines. I guess it's probably something wrong with my laptop.
I don't think so. I think it's the manner at which you copy the text. So if I copy the text out of my little notes screen, it does not automatically execute. But if I copy the text out of this notepad, it is automatically executing the code, the statement. I think I was gonna, yeah, this
Sorry for interrupting it again.
is break time. So I just wanted to type out and show you that you can actually force those carriage returns just by not putting in the semicolon.
You know what, Kathleen? I'm so sorry. I just retyped everything in a notepad and it worked.
It worked for you? Okay, great.
Yes,
Well, it
sorry
is-
for the
it's-
confusion.
No problem. It's 12:01, 15 minutes. Come back here at 12:16. Dance during the break, stand up, move around, and I will see you in just a few moments. All right, I'm coming back. If you guys are there, can you see my screen? Or do we get a black screen again? How we doing? Everybody back?
We are here.
Can you see my screen?
Miss Blank.
Yeah.
Yeah, I can see your screen.
You can? Okay.
Yes.
Okay. So I just wanted to go back what we talked about in the last section. We started looking at min and max. Our syntax has been the same. The only thing that's changed is that aggregator function. Then we added on a component to evaluating min and max, sum and average with group by. And now we've just gone through and looked at using group by with counts and with min and max. So if you take a guess, we're going to now look at using group by with sum and average. So moving on, let me see if let me know if anything is going wrong with the display. So now I'm on a slide that says group by with sum and average functions. Now we are going back to that the gender breakdown of salary. But instead of looking at the min or the max, we want to see the sum. An evaluation like that is going to be common if it's budget time, annual budget time, company. You want to know what their total salary overhead is for the company. And this is how that would break down. All right, so I'm selecting the gender field. I'm grouping by the gender field. Then I'm putting in my aggregate there on the salary field, which is summing them up. And I see that for each different value in that gender field, I get a total. And I'd have to break out the calculator, but if I did, those are the values that I would see. Similar to sum, we want to look at average. This is also a common assessment if you work in a compensation department and you need to determine what the midpoint is for a specific job. And that helps when you're making an offer to a candidate. You kind of know where your current employee, what your current employers are making, and it gives you a better idea of what you want to make an offer on to keep that new person in line with pay as the existing folks. So that is always, of course, dependent on skill, but we're not talking about that today. All right, so for my table, same syntax, we're just changing the word salary. So instead of getting sum, we get that midpoint. So in this particular example, we're going to find the total amount of invoices by country. And so in my result table, I want to see the country name and the total amount. So here's my statement. I want to see from the invoices table. Yep. So from the invoices table, there is a field there that is billing country. And I want to see how much I have sold in each of those countries. So I, of course, bring back the country name, grouping by country name, and then summing up the total values in the totals field. Hit that. You can see that got the UK made $112. And let's see, France, $195, Brazil, $190, Canada, $303. All right. So that is an easy way to kind of use those different aggregate functions. It's really easy to kind of change those up just by changing that function keyword. And we saw an example earlier where we were looking at the milliseconds for a track, for an album specifically, but what was coming back to us was the album ID. And it wasn't really that valuable to us. We could, of course, see the milliseconds or like max milliseconds or short milliseconds by album, but an album ID isn't very meaningful to us when we're reading a data set. What would make it more valuable is if we could have brought back the album name. So we brought back the album ID from tracks, and then, for example, the shortest track. But over here in the albums table, that's where we have the album title. And that would be a lot more meaningful to me if I was reading the data. So that introduces us to the concept of joins. And this is where it blows up. Much bigger world once we get here. So for joins, you have different join types. You have something called an inner join. You have something called a left join. And so to discuss what joins are, they're used to combine two or more tables into a single, they say table, but it's a data set, right? It doesn't have to be a table. It's just a query. It can be an ad hoc query. It can be a query that you save to your database, then build reports on. And joins are usually applied based on what we call keys that define the relationship between the tables. So keys, another word for that is the common field. If we're going back to our ERD, you'll notice that with the tracks example, there is an album ID field in tracks, and then there's an album ID field in albums. You'll also note that there is this line that links the two. And what this is telling us is that you find a link between what the value is in tracks versus what the album ID is in albums. So if we were trying to join those tables together, this would be where we want to make that link, where we'd want to make that combination. So we introduce a concept here of primary key and foreign key. And so we, in most cases, are making joins based on these keys, because with primary key, you're going to find that that value must be unique. So when you take a look at an albums table, for instance, you are not going to have an album ID of 2 multiple times. Just for each album, you're going to have a unique ID. And that is the definition of what a primary key is. So when we get into the join, then we introduce the concept of foreign key. And that's where we see foreign key referenced once we're trying to establish the relationships. So different types of joins: inner, left, right, full, cross, and self. Your simplest join, and the join by default, is your inner join. So when you're writing out joins, if you don't specify inner, the system just assumes inner. So inner, it returns common records found in both tables. The left outer join, though, it returns all records from what's considered the left table and only matching records from the right table. So where an inner join, I say, bring back the albums from the tracks table, or bring back the albums from the albums table, I only want to see records come back where there is a match in the tracks table. Where we have a left join, let me rephrase that. So where we have an inner join for albums, I want you to bring back records where there's a match. So where it finds an album ID in the tracks table, it may bring back 10 records, even though we have 15 albums. This is just an example. Where we get into the left outer join, if we have 15 tracks or 15 albums in the albums table, I want to see all 15 of those albums listed in my result set. And if I don't have a match in the tracks table, just bring back null, that it didn't find a match, because I want to see where we don't have a relationship in those two tables. And then you get into right join, where it's the opposite, and it returns all records from the right table. And in our example, that would have been the tracks table, and any matching records from the left table or the albums table. Full outer join, that returns all records of both left and right tables. Cross join returns the Cartesian product of records in joined tables, and a self join, a join of a table to itself. A good example of a self join is, we use that a lot in my experience with Oracle's tables store the employee name and then the supervisor ID in the same table. And so oftentimes, in order for us to see what the full name of the supervisor is, we have to join the employee table to itself, because that table is referencing an employee as a supervisor within that same table. Inner join, let's look at examples. So inner join, most common type of join. Inner join selects all rows from both participating tables to appear in the results, and only if both tables meet the condition specified in the on section of the syntax, it's only going to return those records. So if you look at the syntax, it is what we've seen so far: our keyword select followed by field names, the from, our table. But notice here it's saying table A. This is where we deviate from what we've been seeing so far. We're going to then say, but I'm joining that table to like records from a different table. And then what I'm joining them on, this is where I would identify the field where they both match, that common field. So essentially this reads, I want you to select things from table A where it equals table B, and where the values for this field match. I don't know if I said that well, but here's a little diagram, and it brings back only the records that exist within both tables together. Okay, so a practical explanation or example of that is we have two tables. One is full of students and one is full of test scores. And in our students table, it shows us the name of the student and the exam that they took and their score. But what we want to know is what is passing. So Clark here took a Python exam but made 60. Did he pass or did he not pass? So then I have to go over to the test table, and I have to see that for Python, the passing score is actually 60. So Clark did not pass. So instead of writing two different queries, what we saw in the past, we can then create a join, and it is a single query. Less work for us to do, more work for our little compiler here. So back to the syntax, I'm selecting my field names, but what's different here is we're now seeing an addition to a field name. I haven't seen this before. This students dot, this is actually the table name of where this field is found. And because we are using multiple tables, you're going to see that we're filling it out a table name, field name, table name, field name. For this one, different table name, and then field name. So my table A I'm pulling from is students. My table B I'm pulling from is tests. And then I want to bring back the name field, exam, score, and then only this passing score column from tests. Where these two fields are related is in this exam value in both tables. So when I do my evaluation, I'm going to say where exam equals some value in students and where exam equals some value in tests. And where they match, because this is an inner join, it's going to bring back records that qualify. So writing this out, I've got my student name, my student exam, student score. I've already listed exam, so I really don't need to see that value come back. Really, I just need to tell the SQL script, the database, that I have a match between these two. And then I want to bring back passing score. So common field in this example is exam. When it evaluates, it actually doesn't find a match for network. And because this is an inner join, we see that that value is not going to come back in our result set because it's irrelevant for what we're trying to see. Nobody takes a network test. We can't evaluate whether or not they pass. All right. So this essentially is what our result set is going to look like, but we said we don't need this tests exam field. And this is what comes back. So we've got 1, 2, 3, 4 fields that we've identified that we want to bring back from the students table, join to the test table on that exam field. And we can see that John passed, Mary snuck by, Clark actually did not pass. Okay. We talk about inner joins. We've had table B. We can do that for as many tables as we need to relate, as long as they're related tables. So table A is related to table B on conditions 1 and 2. Table A is related to table C on other conditions. So back to this view.
Catherine, can I have a quick question?
Sure.
Pass. So on that inner join example 1, I understand all that, but you only selected it's from students table only, right?
It actually is from students and from tests because it's a little, you'll get used to reading it, but you're saying from students table joined to the test table.
Okay, so as a syntax, we just write from students. Oh, so we're stating both of them. The test goes on to the inner join.
Right.
Test.
And so that second table that you're referencing, you have to tell the system how those two tables are related, and that's where we get this on section.
So we don't. Okay, so we don't have to say
test there.
Okay, gotcha. We don't have to state that tests next to students table. It goes under inner join statement.
It does. I have seen, you may see older queries where they just separate out these table names with a comma. It is assumed that you are identifying an inner join, but this particular, the way this is written out, this syntax, it's one, very easy to read, much easier to troubleshoot for anybody that comes behind you and has to make changes to your code. And when you are typing things out using indentions, it's just to the eye, you see what you're working with much better. And I'll show you an example of that as we get into as we use an example. Like, see how we use indentions here. It's much easier to see that. So we've got our select clause here where we're picking out our columns, and then we start that from. I typically, when you see lines 3 through 6 here, I typically indent them one more time so that my parent table, my table A, it's easy to identify, and then I go on to these child tables is how I refer to that.
I see that. It's easier to see, definitely.
It is. It's easier to read.
All right. Thank you.
You're good? You're okay?
Yes, thank you.
Let me know if you're not okay, anybody, because this is where we really start to see a lot of that tough conceptual stuff as we kind of move into our third class as well. So primary key, foreign key, these are two concepts that are very important when you're talking about joins. When you're joining two or more tables, you use these keys to build the join on. This is the relationship between the table. Primary key is a column in our table that makes each row unique. So going back to that album example, for each album, you're going to have a unique identifier for that album. The foreign key is a column in a table that uniquely identifies each row of the other table as it relates to that current record. So in our example here, where we have albums and we have tracks, where we have an album ID, you may see album ID repeated in our tracks table because I said there's multiple tracks in an album. But if I go out and I want to see what that album name is, it is going to find out based on this value, the single record that that particular code represents. So this would be our primary key. This would be our foreign key. And there is a possibility when you're dealing with a foreign key that it occurs multiple times. Okay. Let's take a look at the genre of each track. Here's a table we haven't used yet. So the genre table, let's take a look at that. Let's see what we're working with. How many genres do we have? So if I go select star from genres, we got quite a few genres, 25. Note, each genre has its own ID. How is genre related to tracks? You can see genre ID here. It is related to genre ID here. And I see that little line in our inner diagram. These are invaluable because if you don't have them, it's a lot of research into how that table is structured to find out how these fields or if these fields are even related. It is possible to have a field name in one table and find that same field name in another table, and they are not related to each other. That, of course, is an example from a very complex database, and our nice Chinook database is a lot simpler. Okay, so 25 different genres. I can expect to see those different genres listed by track for each record in the tracks table. Where you see this little character at the start here, this is telling us that there is a unique value for each track. And we may find we've got this little spread apart. I don't know, it looks like a pitchfork. It can be found multiple times in the tracks table. And that's how we make our association of a single genre can be applied to multiple records in the tracks table. Let's go here. Let's put in an example statement. All right, so we want to bring back, of course, our track name and then what genre. And if you note, in the tracks table, we have the name field, and in the genre table, we have the name field. If I were to equal name to name here, it's probably not going to find a match unless the name of the song, it happens to be also coincidentally the name of one of our genres. So again, going back from, where am I pulling this information from? One, I want to see the track name, and then two, I want to see the genre name. So I'm pulling from, and I'm joining tracks to genres. If you take a look here where we have join, in our previous example, we used inner join. If I use join, it assumes inner join. So one and the same. Where do these two tables intersect? What is the common field? It's that genre ID. So we've called our first table tracks. We've identified that we want from the tracks table the field name. And then from our table of genres, we've identified that we want the name field from genres. All right, So we had, what do we have, 3,500 tracks. So we've got our track name, blah, 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 all the way to our pipe here. And then there's our genre. You'll notice for this particular track, pipe genre, we find that genre again here. So even though there's only a single classical genre defined in our genres table, I have many tracks that are classical. Talk about aliases. Again, going back to aliases, this is where I was talking before, we have, we usually see for a select statement that field name, we want it to be something that is easier to read. So we'll say field name as, say, track name. We want it to be labeled track name. And then for this one here, G name, we want it to be labeled a genre name. So that's where you'd see maybe T dot name as track name. Well, in our previous example, we referenced tracks, the tracks table and the genres table. And then up here, we would see tracks spelled out. And then here we would see genre spelled out. But to make this a little easier to type out, so I don't have to type out the table, the whole table name before the field name when I have joins, I actually give the tables a little alias. But you'll notice there's no as here. I could have an as here, but when you're looking at code, again, it's style, it's preference, but you typically don't see as after the name of the table. So in this case, this is an example of a table alias. And now quickly we can go through, and if we wanted to bring back from the tracks table the name value, the composer, you would put in your field selection, you'd have t.name, t.composer. And then once we go over here and we pull in data from the genres table, since we've given that a short name here of G, I only have to type out G name. Same goes for on, where we're establishing that common field. So the common field from tracks is genre ID, and the common field from the genres table is genre ID, but it takes me a lot less time to type out that versus typing out that. So here's one. Here's the longer version. Task numbers. So all right, so going back to our tracks and genres, we want to bring back the genre name of each track. We're matching it on genre ID, that's our common field. And we can see for all of these tracks here in this example, they're all the same genre. I keep saying drama, I apologize. So I'm going to execute this particular query, and I should see back if I'm pulling in name and I'm pulling in the name of the drama, not doing it on purpose, then I should see in my result set my track name and then that it's the rock genre. Same thing. Also the wall, rock genre. You can see that if we execute that query here, that's exactly what we get back. That's what we wanted. So another example of that, so we want to find the customer name of each invoice, and the results are invoice ID and customer name. So looking at this guy, but instead using our invoice table and our customer table, we want to bring back the invoice ID from invoices, and then the customer, it says customer name. So we'll be pulling out two different fields. So I'm going to bring back the first name of the customer and the last name. All right, so my two tables, invoices, customers, my fields, invoice ID, first name, last name. how are these two tables related? Well, I have in my invoices table, I actually have, let me bring up an example. I've got my invoice ID and then I've got my customer ID. So then when we go back to our ERD, we can see that the match, this is really floating in the wrong spot, but the match really is between customer ID here and customer ID here. So if I put in my query, combined a couple of different concepts. I'm bringing back the invoice ID from the invoices table. Then I'm bringing back two field values from the customers table, and I'm matching on that customer ID field. So if I run this, you can see that Luis Rojas or Louis actually has multiple invoices here. Mark Taylor, multiple invoices here. And that is how we find the customer name of each invoice. All right, so we're at the end. We kind of took our most complicated concept and reviewed that at the end. From this concept, we're going to go into the next course and we're going to build on this further. So we talked about simply two tables. We saw that we could join on multiple tables. And that's where the complexity and the true value of writing SQL comes in, is when you start making those joins, because we actually start bringing back values from what we previously were running multiple queries for. We actually execute a single query. It's intelligent enough. It brings back multiple facets of data based on the query we wrote. So I'm going to finish up the class at this point. Go into your Pear Deck, take a look at the examples that we worked with today, give yourself a review, and enjoy your week. And I'll see you here next Saturday, and we'll build on what we've talked about. Because if you look at our ERD, we've got a lot of tables, a lot of related fields, and in some cases, excuse me, a table can be related to multiple tables here. So we'll take a further look at that. I hope you guys have an excellent week. And if you have questions, go out to Slack, place them on Slack, and I look forward to seeing you again.
Thank you for the lesson.
Thank you.
Thank you for joining me. This is a lot of fun. I'll talk with you soon.
Thank you.
Thank you.
Thanks.
Thank you.
You're welcome.